Alright guys, hello and welcome to today's lesson. This is Mr. Ludden and today we're going to be having a look at sine, cos and tan. This is a follow-on from my lesson on Pythagoras Theorem, so if you haven't watched that, I would recommend going back and having a look at it. I will put a link for that in the description below. If I go through any key notes or anything important from today's lesson, I'll put those in the description below as well, so that you can copy and paste it into your own notes. Alright, so the reason I sort of broke trigonometry up into two videos was the fact that Pythagoras Theorem and sine, cos and tan, they're linked very closely together, but there's one sort of fundamental difference. The similarity between the two of them is that both of them deal with right angle triangle problems. So if you have a problem with a right angle triangle in your junior cert, the chances are you'll either be using Pythagoras Theorem or sine, cos and tan. And the difference between the two of them is as follows. In Pythagoras Theorem, you have your right angle triangle, and let me draw a better line there, that's a bit better. You have a right angled triangle. In sine, cos and tan, you have a right angled triangle too. So that's a similarity. The difference is, in Pythagoras' theorem, you are told information about your sides. So x, y, and z. So it only deals with the sides of your triangle. You do not know what this angle here is or what this angle here is. With sine, cos, and tan, you will be given one of these angles. So just to label it like I've labeled my other triangle over there, and I need that side there. Like a classic example is you'll have an angle here, you'll have a side here, and you'll have a side here. And what'll happen is, like with both of these, let's say Pythagoras here, you'll be given a right angle triangle and you'll be given values for, let's say, x and y, and your job will be to find out what z is. The exact same thing goes on over here. You'll be given like the value of y and z, and you'll be asked to find what the angle x is, and that's where the sine, the cos and the tan come into it. You might have seen those buttons on your calculator. We'll be touching on those in a couple of minutes time. But basically, in summary, Pythagoras' theorem deals with just the sides of your triangle, and sine, cos and tan deal with making a relationship, between the angle and the sides in your right angle triangle. So just to start at the very start, and just to show you where that ties in with your trigonometry for your junior cert. First of all, trigonometry, the trig stands for triangle. The onometry stands for measure or measure of. So if you put those two things together, trigonometry is just about measuring triangles. So for your junior cert, you can split that up into two groups. Your right angle triangles, where we use Pythagoras' theorem if it's all sides, and sine, cos and tan if it's angles and sides. So that's what we're going to have a look at today. I suppose just to touch on your non-right angle triangles, so most of your scalene triangles, most of your isosceles triangles, we'll cover those in geometry, and also when we look at congruency with similar triangles. And we haven't had a look at that yet. I will be doing videos on those in a little bit, but for now I'm going to put lines through those. All we're dealing with today are right angle triangles, and especially, I don't want to put a line through that because that's what we're looking at, especially sine, cos and tan. Alright, to give you just a really broad idea, without any formula, without any numbers, well, there are numbers in my diagram here, but with the least amount of numbers possible, just to give you an idea of what sine, cos and tan actually do. If you look at the two triangles that I'm after drawing, they're two right angle triangles. Triangle number one, we're given an angle of 30 degrees, and triangle number two, we're given an angle of 60 degrees. Now, in primary school, like, you would have learned how to use a protractor, you would have noted like acute angles, right angles, But what you wouldn't have done is looked at like how these angles here relate to the given sides in your right angle triangle. So basically the relationship between the angle and the sides. So if you look at my first triangle here, you notice that like my side, my vertical side here and my horizontal side, like there's not much in the difference between the two of those. Like they're more or less, they're nearly the same. But this side here is going to be a small bit shorter than my horizontal side. If we sort of compare that to what's going on my triangle on the right hand side, you notice that by comparing my vertical side to my horizontal side, my vertical side is a lot bigger. And you'll notice that that has an impact in the angle that is opposite it. So like this side is big, so therefore the angle 60 is quite big. This side, if we look at my triangle number 1, this side is quite small. And my angle 30 is quite small as well. So what we're going, now that's a really basic sort of idea of what sine, cos and tan are going to do. We're going to look into that in a small bit more detail in a minute. But basically the idea I want to get across here is that sine, cos and tan are going to help us look at the sides of our triangle and give us an idea of what's going on in the angles as a result. Okay, page 16 in your log tables, you might remember that from Pythagoras Theorem, the video I did a little while ago. I'll just start from the start again. Page 16, your log tables, you notice that the top half of your page talks about a triangle where you're not told that any of the angles are right angles. So remember, for your junior cert, you're only dealing with right angle triangles in trigonometry. So you are. So your triangle up here, basically, long story short, this is leaving cert. Leaving cert. Stuff. And your formula here, we're not going to have a look at those today. We'll have a look at those when you get to your leaving cert. So you'll notice that down at the bottom of the page, your right angle triangle and the diagram that they give you, this is what we're going to be sorting out today. Now you might remember at the bottom here, c squared is equal to a squared plus b squared. That was our relationship, our Pythagoras Theorem relationship. And you'll notice that c, a and b are all small letters. So, and that relates to the a, the b and the c in your diagram. And that's great. And you've just compared all the sides together and you've got a relationship between all of those, and that's great. However, we're not looking at that today. We're looking at what's up above. We're looking at sine, capital A, cos, capital A, and tan of capital A. So what that tells us is, I'm just going to get rid of some of my red marks here just so I can be as clear as possible. Your sine of capital A, it means that whatever size the angle is, it's going to be the same as the ratio between A and C. So if you have a value for A and a value for C, if you divide them by each other, you will get a value for sine A. The same for cos A and the same for tan A. You'll notice that if we just look at the fractions here, A over C, B over C, and A over B, basically they're just different combinations of the three sides in my right angle triangle. So you've got A and C together here, you've got B and C together here, and then you've got the combination of A and B together. So between sine A, cos A, and tan A, they're just different combinations of the sides in your right angle triangle. Now, without context or without numbers here, that might be a small bit hard to grasp what's going on here. So what I'm going to do is we're just going to take a step away from the log tables for a minute, and I have this diagram here to show you. So I'm not going to worry about just what's here at the moment. I'm just going to worry about, I suppose, labeling our right-angled triangle when we have one. So in your right-angled triangle, you've sort of like 4 pieces of information, and you'll be able to see them there: adjacent, opposite, hypotenuse, and your angle. Now that symbol there, it's called theta, and it's a symbol used to show you angles, often in maths. But it's the exact same as like x, y, any variable that you can think of. But sometimes they just want to be fancy and they use that. So that represents the angle. But you'll notice we have 3 words to describe the 3 different sides. And this is really, really important, that you're able to label the triangle that you're given in your question properly before you start your question using sine, cos, and tan. So in your triangle, and I've done one down here, you'll be given your angle. And in this one down here, I've done out the classic Pythagoras Theorem triangle, the 3, 4, 5 right angle triangle, and I've measured out the angle here as well. It comes out at roughly 36.9 degrees. Now, if I was to label this triangle in the same way that they've labeled this one up here, we're just going to walk through that. From our Pythagoras Theorem video, we know that the longest side in our right angle triangle is our hypotenuse. So I'm going to label this one up here as H. I'll put a square around it. So that side there is my hypotenuse. And that's the one we're always going to put in first because it's the easiest one to remember. The hypotenuse is the longest side. It's the one opposite my right angle. It's really hard to miss. Now, you might have seen or peeked at the opposite side up here and also the adjacent. And that depends on what angle you're given in your question. So in this question here, you're given the angle 36.9 degrees. Now, we've labeled the 5 as the hypotenuse. We've labeled that. That's done. We have to label what 3 and 4 are. Is it going to be the opposite? Is it going to be the adjacent? Which one is which? And in order to do that, you need to know what angle you're actually working with. In this question here, you're working with the angle 36.9 degrees. The side opposite that, so the side opposite, the side furthest away, the side that is not, I suppose, touching the angle. If you notice that the side here labeled 3, it's not one of the sides that makes up the angle 36.9. The angle 36.9 is made up of the side labeled 5 and the side labeled 4. So the side opposite your angle is 3, and I'm going to label that opposite, OPP. And I'm just going to put it OPP because if I put it as O, you might think it's 0, and then that would make no sense because you can't have a triangle with one of the sides which is 0. Once you have your hypotenuse and your opposite side identified, the last thing you have to do is label your adjacent side. Now, if you looked up the word adjacent in the dictionary, you get something like beside or next to. Beside or next to, I think, is the best words that I can think of in my head. And basically what they're saying is that your adjacent side is the side beside your angle, but it's the one that's not your hypotenuse, because your hypotenuse is labeled already. That was the first one that we did. So in our situation down here, 4 is going to be my adjacent, ADJ. And once you have your triangle labeled, it's just a matter of sort of looking at the different ratios that you're given. And these are given in your log tables from a minute ago. If I just zoom back to those, you know that sine A here, if we just look at sine A, and let me just get rid of the red here around it, if we look at sine A, it's A over C, so A over C. Now you'll notice in your log tables they haven't labelled the right angle triangle here. But for us starting off, even going up to leave insert, I always get people to label their triangle at the very, very start, because if you don't label it right at the very, very start, then it's very difficult to sort of get that back in the middle of your question or to realize where you've gone wrong. But you'll notice that for sine A here is A over C. It's your opposite side over your hypotenuse in that question. If we were to look at what's going on here, and I know I have a lot of red in here, I'm just going to take some of that away. Let's get rid of some of that. If we were to sort of put our information now into the three sort of formula, sort of rules that we have here, I'm going to put my numbers and my degrees in, and then we're going to have a talk about what they actually mean, so in context. So up till now, you might have been looking at this and saying, well, why are you getting me to label this? What does it matter? I have all my information. What's going on? Once I have my numbers put into my formula here, we'll have a talk about that, and hopefully it'll make it a small bit clearer. So if we take the sine of my angle theta first, and maybe I should have said this at the start, sin here is short for sine, and that's the reason that I pronounce the sin there as sine. Cos is short for cosine, and tan is short for tangent. You'll have a look at what those actually mean, I suppose, in a bit more detail at leave insert. But I suppose just so you're aware, when I say sine, I'm talking about the sin there. Okay, if I apply my rules from here to the question that I've just done down the bottom right hand corner, I find that the sine of my angle, and my angle is 36.9, is going to be my opposite over my hypotenuse. In my question here, my opposite is 3 and my hypotenuse is 5. What that tells me is that if I have a right angle triangle with 36.9 degrees as one of my angles, then the ratio between my opposite side and my hypotenuse is going to be 3 over 5. So if we put 3 over 5 into our calculator, it's going to be 0.6. Basically what they're saying is, like, they're comparing the opposite side and the hypotenuse together, and they're saying that my opposite side here is going to be 0.6 of my hypotenuse, and that's the case here. So that was my opposite and my hypotenuse that was being, I suppose, compared together. If we look at cos of my angle, cos of 36.9 is going to be my adjacent over my hypotenuse. So my cos is my adjacent, which is 4, all over my hypotenuse, which is 5, and that's going to be 0.8. So that tells me that if I have a right angle triangle, and if one of my angles is 36.9 degrees, then the ratio, I suppose, between my adjacent side and my hypotenuse is going to be 0.8. If you look at it, 4 is 0.8 or 0.8 of 5 there. If you multiplied 4 by 0.8, you would get 5. Apologies, the other way around. If you multiplied 5 by 0.8, you would get 4. Apologies about that. Okay, the last one. You'll notice that for cos, you've looked at your adjacent and your hypotenuse. So for sine, you've looked at your opposite and hypotenuse. For cos, you've looked at your adjacent and hypotenuse. And for tan, we're going to be looking at our opposite and our adjacent. So tan of 36.9 is going to be my opposite over my adjacent. My opposite side was 3 and my adjacent side is 4. And that's going to be 0.75. So basically what they're saying is that 3 and 4, it's telling you the relationship between those. So 3 is 75% or 0.75 of the number 4. So that's all well and good for an example like this one here, where I have 3, 4 and 5 and I have 36.9 degrees. I have my angle and I have all 3 of my sides. Everything's great for that. However, that's not the extent of what the junior cert might ask you. For your junior cert, they're going to take away certain pieces of information of a question like this, and they're going to ask you to work backwards to find out what the missing piece is. Now, before we have a look at our exam questions, I suppose, I'll just go back to our log tables here. And yes, these things are in your log tables, like what cos A actually means, what sin A actually means, and what tan A actually means, what sides of the triangle you're putting together. But I suppose looking at this for reference is the best, just to make sure that you're correct in this is the best. I wouldn't be relying on my log tables for you for the exam. Just I suppose looking at timekeeping from a timekeeping point of view. So learning this thing here, and again I have a lot of red lines, but learning this here will be extremely beneficial to you. And the way that the way I was taught it was something called SOHCAHTOA. SOHCAHTOA. So it's sort of like a chant. And what that sort of breaks down to is, if you take the first one here, sine of your angle is going to be your opposite over your hypotenuse. So opposite over hypotenuse. The C stands for cos. The cos of your angle is going to be your adjacent over your hypotenuse. And you might be able to guess the last one. The T stands for tan of your angle is going to be your opposite over your adjacent. So it's really, really helpful to learn these. If you forget them, they are in your log tables, but it will definitely speed up your calculations learning those off. Okay. Draw on your calculator as well. And I just took I copied and pasted a picture of a calculator here. You might have been messing around with them. You might have seen. Those 3 are your sine, cos and tan buttons there. And if we go back to the question that we were after doing, I'm just going to go back here. If you put sine of 36.9 into your calculator, so if you press, your sine button there, and brackets will come up, and if you press 36.9, I'm just going to do that here on mine, sine 36.9, you get a 0.6004, etc. What you should get is 0.6. The reason you're getting 0.6004 is because I sort of rounded the 36.9 degrees there. Actually, that's 36.8 something. So that's just sort of like an estimate of sorts for my answer. Just in regards to an exam, like obviously this was just an example of showing you what's going on, like the 0.6, the 0.8, the 0.75. If you put sine 36.9 into the calculator, you'll get 0.6, but you get a few decimals after that, and that's just because I rounded the angle to make it easier on myself, just for explaining wise. In exam questions, you'll be given exact amounts. You'll be given you'd be told whether to put it to 2 decimal places or 3 decimal places. We'll have a look at that in a couple of minutes. So we will. My main point here was just showing you where the buttons on the calculator was. You'll notice also that I'll just take the red away. Just up above my sign button is a sign and then a little -1, and the same for cos -1 and tan -1. We'll come to that in a minute too. They're going to help us out in a little bit. Okay, I just talked for 25 minutes about like what sine, cos and tan are, but right now what we're going to do is we're going to jump into an exam question, and we're going to use sine, cos and tan to figure out what's going on in this question here. So this question came up in 2019, question 13a, and it says use trigonometry to work out the value of x in the diagram below. Give your answer correct to 2 decimal places. Okay, so the first thing we're going to do, and I've written it up here just to remind myself, we're going to label our triangle. So the first thing we're going to do is we're going to say that's my hypotenuse. We're given our angle here, it's 20 degrees, we're given that angle. So that's going to indicate what we call our 6 and what we call our x. Remember, we need an opposite and adjacent. So the side opposite my 20 degrees is going to be my adjacent, ADJ, and the side beside it, side opposite. You know I've been talking for a while. The side opposite my 20 degrees is going to be my opposite, of course, OPP. And the side beside it is going to be my adjacent. Okay, and obviously just be careful there. I nearly labelled this one here as my adjacent by accident. Yeah, just be careful of that. So we've labelled it correctly, just about. Now we're going to choose. We're going to choose whether we're going to use sine, cos or tan. So for this question, we have our opposite and we have our adjacent. We're told nothing about the hypotenuse, so we don't want anything to do with that. So what we need to find out is which one out of sine, cos or tan deals with my opposite and my adjacent. So opposite and adjacent, I'm going to go back to this slide here. And what we need to find out is which one of these 3 things deals with my opposite and my adjacent. So for sine of theta, I have my opposite, but it deals with my opposite and my hypotenuse. I don't want that. So this one isn't going to work for me. My cos of theta deals with adjacent and hypotenuse. Again, I don't have my hypotenuse, so I don't want to deal with that. That leaves me with tan theta, and this is our last hope. It better work. So let's say it deals with opposite and adjacent, which is exactly what we wanted. And I was just in the middle of writing that. Adjacent and opposite. So adjacent and opposite, comparing those 2 sides, or I suppose the trigonometric ratio that describes both of those is tan. Just by the way, sine, cos and tan are sometimes referred to as trigonometric ratios. So it's a big fancy name for them. Basically, that means like it's part of trigonometry and you're dealing with the ratios of 2 sides of your right angle triangle. Okay, so this is the piece of information that I came for, that tan deals with adjacent and opposite. So I'm going to write that down. I'm going to say over here that the tan of my angle, and I'm just going to write the angle theta there for the minute, is my opposite all over my adjacent. Okay, once I've chosen which trigonometric ratio I wanted to use, I can take that off, and I'm on to sort of step 3. So to sort out step 3, I need to substitute my information from my question into my equation here. So in my equation here, tan of theta, well in my question here, the angle that I'm given is 20. So I'm going to say that that's tan 20. And that's going to be equal to the opposite over the adjacent. Well, my opposite side is 6 and my adjacent side is x. So right now, what I have And I'm just going to go on to the next slide here and just write that out again. I've got tan 20 is equal to 6 over, let me write that again, x. So right now, once you get to this step here, this step isn't really a trigonometry question anymore. All you have to do with this step here is to tidy it up. So that's our fourth step. So we've done our substitution, we've got to tidy it up. So this isn't a trigonometry question anymore, it's an algebra question. You've got to find out what x is. The hardest part of the question is getting to here. After this, it's just your algebra that you'll be relying on. So there's a couple of different ways to finish out this question, and then we'll have a look at the marking scheme. The way I like to do this is, seeing as we have a fraction on this side, just one fraction, if we could compare it to a fraction on this side here, then it might make my job a small bit easier. Unfortunately right now, tan 20, like that's not written as a fraction, but I could write that as tan 20 all over 1. The reason I'm trying to compare these as fractions now is because the x is my denominator here. If the x wasn't my denominator, if it was x over 6, so the other way around, I could multiply both sides by 6 and I'd have my x on its own and I'd just work out my other side and I'd be okay. However, I want to get my x like out from that fraction over there. So I've got tan 20 over 1 is equal to 6 over x. Remember, I haven't changed the value of tan 20 because if you divide something by 1, you still get the same thing that you started off with. So just to explain my next step, I'm just going to go over here and I'm going to talk about inverting fractions. If you had a half, if you sort of think back to like primary school, you would have learned that a half is the same thing as 2 over 4. So that right there is a fact. A half is the same as 2 quarters. What you mightn't have realized is if you've got like one fraction equal to another, if you were to invert both of those, so in other words, if you were to flip both of those, swap the numerator with the denominator, in this one here, you'd end up with 2 over 1 is equal to 4 over 2. And you'll notice that my first statement was correct. When I inverted my fractions, 2 over 1, 2 divided by 1 is the same thing as 4 divided by 2. The statement holds true. So what I'm going to do is I'm going to apply that logic here to my question over here. And I'm going to say that, well, if I invert both of these fractions, so this one here and this one here, if I invert both of those, my equation is still going to be true. Remember, I'm doing this to get x out from the bottom of this fraction over here. So I'm going to have 1 all over tan 20 is equal to x over 6. And now this here, the line that I'm on, is a whole lot nicer of a question to deal with. If you look over on the right hand side here, I've got x over 6. But I don't want x over 6, I just want x on its own. So what I'm going to do is, I'm going to, I'll just get rid of this just so I have a bit of room. And brackets here, I'm just going to say multiply by 6. If I'm multiplying my right hand side by 6, I'm going to end up with x on its own here. Of course, if I multiply this side by x, I've got to multiply my other side by x as well. Or by 6. Did I say x there? I meant 6. So by multiplying both sides by 6, I get x on its own on one side, and on this side I'm going to get 6 all over tan 20. At this point, you've got x on its own. So on this point now, you're going to your calculator, and in your calculator you're going to plug in 6 all over tan 20. If you do that, you will get 16.48486 is equal to x. If we look back to our question, like technically we've answered it, but let's see, give your answer correct to 2 decimal places. They only want 2 decimal places. I've given it to, I think, 5 decimal places there. So in order just to tidy that up, just to make sure we're getting our full marks, that's going to be 16.48. Now let's see, did they give us, they didn't say centimeters, they didn't say meters, so we don't have to put centimeters or meters in because there was none mentioned in the question. So that right there is our answer. If we have a look at the marking scheme, your marking scheme looks like this. And you'll see that they've done it in 3 lines, what I've done in 1, 2, 3, 4. They've done 4 lines, but often in the marking scheme, they show you the bare minimum of what you need. But in reality, your workings out will be a small bit longer than that. So you'll notice that tan 20 degrees is equal to 6 over x. We got that. We got this, our second line, and we got x is equal to 16.48. We got that. So right now we're getting our 10 marks. But just looking at our marking scheme, we would have lost a mark if we didn't round our answer. And we would have lost a mark if our calculator was not in the correct mode. So if I just go back to the picture of my calculator, you'll notice that what they're saying there is the correct mode of your calculator. You'll notice on your calculator you should have the letter D in bold there up on top. That means your calculator is working in decimals. Apologies, not decimals, degrees. So this here means that your calculator is working in degrees, which is what you want, because in your question, you notice in your question it was 20 degrees. The opposite of that is radians, and that's another way of looking at angles, but you don't look at that until you're leaving cert. So if you have, if you don't have the D there at the top of your calculator, you might have a black sort of square that says R in it. If you have that, then you need to reset your calculator or go through the settings so that you're working in degrees and not radians. So before you start any of these questions, just make sure that the letter D is blacked out there up on top. So back to our marking scheme, that was those two. So you were losing 1 mark for those. Basically your high partial credit is if you've made a mistake, but then your low partial credit, you're getting 2 marks for any work of merit. So even if you started labeling your sides of your triangle using your 20 degrees, so even if I had seen like hypotenuse written down in the right place on your right angle triangle, I had to give you 2 marks. So even starting out the process there gets you your marks. Basically they were throwing 2 marks at you if you'd started that question any way at all. Okay, so just to go back over that question, what we did is we labeled our right angle triangle, we chose which trigonometric ratio we were going to use, whether it was sine, cos or tan. We had to use tan in this one because of the information given, because we had our opposite and our adjacent. We substituted in our values and we tidied up. There's one last question I'm going to have a look at, and it follows on the same lines as what we were doing. So is this question here in 2017, question 8, question A, part I. Basically this bit up here just tells us about what's going on in the diagram here. So I'm just going to skip straight to question 8a part I, and it says use trigonometry to find the size of the angle y. Give your answer correct to 1 decimal place. So to find my angle y, you'll notice that angle y is part of this triangle here. So in this question I have 2 triangles, like one on top of another. For the first part of my question I only need the bottom triangle to sort out what's going on. So what I'm going to do is I'm going to redraw that. I'm going to redraw it here. And I'm going to put in what I know. Y, and I've got 12, and I've got 10. And just like the last question, I'm going to label my my triangle first. So my 12 here, I'm going to start with my hypotenuse. My 12 is the longest side. It's opposite my right angle. The side over here, the one that's not marked, is going to be my opposite side. So OPP, opposite. And the side at the bottom is my adjacent side. So labeling, very important. If you have it labeled correctly, you're getting your low partial credit, so the first bit of your marks anyways, and anything after this, you're building up your marks all the time. So once you've got it labeled, you've got to choose whether you are using sine, cos, or tan. So in my diagram here, I've got my adjacent and I've got my hypotenuse. So if we go back to where had I written? Back here. The one out of my trigonometric ratios that uses adjacent and hypotenuse is cos. So this one here. So I'm just going to scoot back to my question. I'm going to say that the cos of my angle is equal to adjacent over hypotenuse. And that's my choose part done. I'm then going to substitute in what I know about my triangle. I'm going to say that the cos, and the angle I'm working with is what labeled y, is equal to adjacent over hypotenuse. So 10 all over 12. And right now, the same as the last question, your question now has stopped being a trigonometry question, and right now it's an algebra question more or less. You've got one equation here and you've got one unknown, the y, and you're trying to find out what the y is. Now in order to figure this out, when you're trying to find out what the angle is, there's just one extra step that you have to be aware of. And for that, I'm going to go back to my calculator. So I have cos y is equal to 10 over 12. I'm going to put that up here. Cos y is equal to 10 over 12. And I've left a space here, and you'll see why in a minute. Okay. In order to explain my next step, I'm just going to do some rough work here. And we had a look at inverses. So when you, if we look back at this slide here that I was doing, this bit here, my inverses. So the inverse of a half is 2 over 1. The inverse of 2 over 4 is 4 over 2. So basically the inverse of something is when you swap the denominator and the denominator. So there's a special type of, there's a sort of relationship between a number and its inverse, and I'm just going to go through it here. If you have a half, and if you get the inverse of a half, you get 2 over 1. If you multiply those two things together, and you can do that on your calculator, or if you remember how to multiply fractions, it's the top by the top and the bottom by the bottom, you'll end up with 2 over 2, which is the same thing as 1. So that's fine. If you pick any other fraction, let's say you pick 1/3, and you get the inverse of it. The inverse of 1/3 is going to be 3 over 1. If I multiply those, I'm going to get 3 over 3, which is 1. And you might think, oh, that's a coincidence. But if you take any fraction at all, let's say we pick 2 over 7. If you get the inverse of that, that's going to be 7 over 2. And if you multiply those, you're going to get 14 all over 14, which is 1. So you might think, what's going on? Why is Mr. Ludden talking about fractions now? This isn't really a fractions question. The point I'm trying to get across here is that if you have a number or something, and if you multiply it by its inverse, you will always get 1 as an answer. So I'm just going to write that down here, and this will be in your notes in the description as well. So when you multiply a number, and going to get rid of this by its inverse. You get 1. And I'll leave that as my example down there at the bottom. Get 1. Alright, I know my writing isn't the best, but I hope you can make that out. Okay, now we're going to take that logic here and we're going to apply it up here. Because remember, we want to get y out of there. We don't want it to be attached to the cos here. We want to get just y on its own. So I'm just going to get a different colored pen here just to show you exactly what I'm doing. Let's go navy. Okay, so what we're going to do here is we're going to multiply cos y by the inverse of cos, and that's where on your calculator, that's your cos button there, but if you see up above it, you get cos inverse, so cos and the little -1. The way you get that is by pressing your shift button and your cos button, and up in here in your screen you should get something that looks like this. You should get cos -1. That's how you get that. So the shift button and your cos button. Now the left hand side here is sort of like my working out, but like the real magic is going to happen over here. So it is. Let me just get rid of that. If I multiply cos inverse by all of this, remember this is an equation, so I have to do the same thing on the other side. Cos -1, 10 over 12. Now I'll just put equals there just so we're sure. On the left hand side here, I've got cos inverse multiplied by cos. Now remember, cos inverse, the inverse of something, multiplied by cos is just going to give me 1. So on the left hand side here, this multiplied by this is just going to give me 1. And the angle I was working with was y. I'm going to be left with 1y on the left hand side. On the right hand side, cos inverse 10 over 12. That's where the button on your calculator comes into play. So you're going to press shift cos to get the cos -1 little sign, and then in your brackets you're going to put 10 over 12. And when you put that into your calculator, you should get 33.557. Now in your question it asked you to 1 decimal place. So to 1 decimal place, that's going to be y is equal to 33.6 degrees. So right now you've answered that question. And again, just to reiterate, just to show you what I was doing here, like this is the bit that you're putting into your calculator. But just to show you what's going on, to get rid of the cos here, and if you are getting the angle in your right angle triangle, to get rid of the cos, you need to multiply it by the cos inverse. So that gets rid of it. That's where your 1 comes from. And this bit right here, the cos inverse of 10 over 12, that's what you're putting into your calculator. Because if you're getting the cos inverse of one side, you have to get the cos inverse of another. Okay, we'll take a quick look at the marking scheme and then I'll wrap it up. So for question 8A part I, they give you 3 ways of doing it. So they do. I'm not going to worry about the second 2. One got that using Pythagoras Theorem. Yeah, they went a long way about it. The way that we've done there is the quickest way of doing it, and yeah, the other 2 are quite complicated by comparison. So we got cos y is equal to 10 over 12. Then we got y is equal to cos inverse 10 over 12. So we got those 2. And then we got our 33.6 degrees. Now, so that gives us our 10 marks. We would have lost a mark if our rounding wasn't correct, or if the units are incorrect or omitted. So if we didn't put the little degrees up there, we would have lost a mark as well. So you'll notice I've put that up there. So just be careful there. That'll be an awful mark to lose. And then again, I like looking at low partial credit. they were giving away 4 marks, so 40% of that question if you wrote down a trigonometric ratio with some correct substitution. So if you wrote down, now obviously like cos was the best thing, was the only thing we could have used the way we went around about this question. But if you wrote down like sine of your angle, what angle were we working with? Sine of y was equal to opposite over hypotenuse. Opposite over hypotenuse. You were getting your 4 marks because you've substituted y in for the angle there. So I suppose the main point I'm making there is don't leave the question blank, because they're literally throwing marks at you for a real basic understanding of what's going on. Okay, I've been talking for 50 minutes, so I'm going to wrap this up now. For your key points for right angle triangles, this is all your Pythagoras Theorem stuff here. And then I suppose this is what we've looked at today. So use sine, cos, or tan when you have 2 out of the following 3 pieces of information. So you're going to be given 2 sides and an angle, and you'll be missing one of those things, and you'll need to use sine, cos, or tan in order to bring that back. And I gave you 2 examples there, one where you were looking for a side and one where you were looking for an angle. First thing you're going to do with any of those questions where you're given an angle and given 1 or 2 sides is label your sides as the hypotenuse, the opposite, and the adjacent. Choose whether sine, cos, or tan is suitable for your question. Usually it'll only be one of those. Substitute your information in and tidy it up. Also, your log tables on page 16 will help you as well. Guys, as always, if I've missed anything there, I'll put it in the description. I think I've got everything. There's quite a lot there, so yeah, I hope that was okay. But like between your sine, cos, and tan and your Pythagoras theorem, you have all your trigonometry covered. So I suppose once you get those nailed down, the biggest problem that you'll have in an exam is deciding, well, whether it's Pythagoras or whether it's sine, cos, or tan you're using. So just remember Pythagoras, all sides. Sine, cos, or tan uses a combination of angles and sides, and then you won't end up like this guy here who's sweating about whether it's Pythagoras theorem or sine, cos, or tan. Alright guys, I'm going to leave it at that. All your notes will be in the description. If I've missed anything or if I think of anything, I'll put it in there as well, so just keep an eye on that. But besides that, thanks for listening. That's me for today. Okay.